Matt Mangriotis, Senior Director, Product Management, here today to talk about high-speed 5G fixed, what it is and why you might use it. Fixed wireless broadband is experiencing a renaissance. With expanding use cases, lots more demand. With the recent pandemic, everyone's figuring out how to do everything from home. Over-the-top media has exploded, and industrial automation is becoming more prevalent. Governments around the world are making more spectrum available every day. The supporting standards like 3GPP, 5G, NR are utilizing technology that's enabling them to become practical. Back in 2012, the ITU released IMT 2020, which set the standards that are being put into practice today. This requires a new air interface. And oftentimes, you think of 5G, you think of the triangle. This includes massive machine-type communications, which means more than 1 million devices can be connected per square kilometer. These are energy-efficient devices. Ultra-reliable, low-latency communications are important. Sub 1 millisecond latency and super reliable communications allow for many new use cases to be developed and used over these networks. The most important thing, enhanced mobile broadband, equally applies to fixed broadband. This means that more than 20 gigabits at the peak can be utilized, and at the edge, perhaps the most important point is at the edge, more than 100 megabits of data can be transferred. But why does this matter for fixed systems? Higher data rates, lower latency, increasing density of networks, all of these things apply to fixed as well as mobile networks. The improved symmetry of a fixed 5G network can allow for new verticals and new use cases, and a private 5G fixed network can be applied as well. Practical implementation can be done in a proprietary or purpose-built system. These innovations are applicable to a fixed system, and by combining 5G protocols and techniques in a purpose-built solution, we can optimize fixed wireless performance while maintaining affordability. So I want to talk a little bit about key 5G radio techniques, namely MIMO and multi-user MIMO. Currently, CISO systems, single-in, single-out systems, have a transmitter on one end and a receiver on the other, and data is transmitted between them. We're approaching the radio such that we're maximizing the theoretical limits of what this link can do. And that really is what's known as the Shannon limit. To overcome this, we've implemented now MIMO techniques, multiple input, multiple output, multiple transmitters, multiple receivers, thereby enhancing the amount of data that can be transmitted across that link. To do this to multiple users at the same time is known as multi-user MIMO. That's a term that was coined by Dr. Marzetta in Bell Labs back in 2010. He at the time was considering the mobile use case. But it equally applies to the fixed use case. And what this means is we have multiple large numbers of steerable antenna elements. There's really no hard limit to that, but they need to be suitable in order to do the beamforming and create this massive MIMO solution or system. Any new solution created in this space must be a beam-centric design, needs to consider beamforming in the design. It's really a necessity in millimeter wave bands in order to maximize the spectral efficiency of the system. So Cambium's philosophy along these lines was getting to multi-user MIMO and massive multi-user MIMO. So we took our single polarized device, which is again one transmitter to one receiver, one antenna element. We double that by adding dual polarization. So we're now transmitting in MIMO, 2x2 MIMO, to effectively double the throughput. We can add more antenna elements and more transceivers to increase the capacity of that link, but there is a diminishing returns on that investment. As you add more and more antennas and you have more and more receivers, you lose the ability to effectively multiply the capacity. Anything beyond 8x8 is considered a massive system. And in order to maximize the throughput of the entire system, you have to have that capability on both ends of the link. And Cambium's philosophy was keep the complexity at the base station side, at the sector level. So we can now speak to add multi-user MIMO systems to the overall solution. We can now speak to more than one subscriber simultaneously, allowing for multiplier in capacity among the entire system. We've been doing this since 2017 with our product known as CN Medusa. CN Medusa was launched in late 2016, and I'd just like to highlight a little bit about how it's being used today, only 4 years later. One of our largest customers, Iolo in Italy, has over 400,000 devices deployed and installed. They're going to cover the entire country by the end of the year, and they're still deploying thousands of users per month. Rise Broadband in the United States covers about 16 different states with varying levels of broadband connectivity. Their highest bandwidth packages are served by our CN Medusa multi-user MIMO technology. In rural Ireland, SkyTel offers their customers a choice. I can deploy fixed wireless system with you today, or you can wait 4 to 6 months to obtain a fiber connection. Almost always, they choose the fixed wireless deployment. They get up and running. The service is so good that when fiber becomes available in 4 to 6 months, they say, never mind, I'm good with the fixed wireless service that you've offered me. And down in South Africa, Herotel, with their network of operators, covers nearly all of South Africa and deploys multi-user MIMO with CN Medusa, where fiber might be prohibitively expensive to do. So why would you consider a 5G fixed solution? There's several reasons. Namely, time to market is a very important reason. 5G fixed solution from Cambium is simple. No complex infrastructure. Fiber rollout can take months or years. It's time consuming and really only applicable where there's enough density to support it. The capital and operating expense of a 5G fixed solution is much less than that of a 5G mobile solution, or even fiber, especially when the density becomes less than in an urban area. And with a 5G fixed solution from Cambium, you can future-proof your investment, utilizing existing infrastructure and migrating, because it is software-defined, migrating to those 5G standards when they become available. Now, Scott showed this slide in his presentation, and I'd like to show it again because I think it highlights where the 5G fixed solution from Cambium Networks really comes into play. Those local ISPs that are competing with satellites for those really rural customers are now pushing towards the higher density suburban customers. The MNOs and MSOs who deploy some of these 5G mobile networks and have urban centers are pushing out towards the suburban and rural areas. And the fixed 5G solution from Cambium, especially in the 28 gigahertz range, really sits in that sweet spot between the two and can serve that and provide for that end solution. Cambium thinks about things in a certain way, and there's a lot of myths about those purpose-built solutions that have been around. In the past, they've been microwave-like, FDD, which results in expensive CPE equipment and limits the amount of roadmap, the ability to evolve to 5G technology, limits the amount of capacity they can increase to. And this really relegates that solution to be a business-only solution, mainly due to the expense. 5G mobile systems, however, they can be great capacity for extremely low distance and high density areas, but that does require that they have a 5G core architecture, which is very complex. And further, the millimeter wave technology, there's no 5G millimeter wave only chipset available right now. It does require a control channel that's sub-6 in order to establish that connection to the millimeter wave band. So Cambium believes that a purpose-built but standards-based solution can provide the right mix. By providing a software-defined radio architecture, this enables future enhancements. It eliminates the complexity that's required to support mobility, eliminates the complexity of an EPC or a core. It's a TDD system optimized for range and throughput, and enables support for those low-cost CPE devices when they become available. We like to use the analogy of 5G fixed solutions being a speedboat targeted for very specific use cases, and the 5G mobile solutions being a supertanker, or something that can carry lots and lots of data, but is very, very expensive to deploy. With that in mind, the 5G fixed solution from Cambium is purpose-built for fixed wireless applications. It can support lower density, but requirements where range is longer, it can still support that as well because of our differentiated CPE equipment. But it eliminates the need for any expensive or complex core network infrastructure, which is typically needed when you deploy a mobile solution. Because of this, it can be a faster return on investment, even in low-density rural environments. And it has native support for 24 to 28 gigahertz without the need for aggregation of a sub-6 channel or a control channel. But it can coexist with those mobile 5G networks because of the frame structure. We adopt just enough of the standard to make this possible. On the 5G mobile side, they have been built to provide for highly dense areas, but that does mean you require that core network, which is a huge capital expenditure. And it's only justified in high dense areas. If you're not highly dense, then it really doesn't make sense and can't scale. So as an operator, you have a couple choices. You can deploy a 5G mobile network, which will give you that ability to support mobility between sites, between cells, end user equipment of any kind that supports typical mobile 5G. But this requires complexity, it requires a huge amount of capital expenditure and OpEx to keep the network going. And your users are contending for capacity on that same network, whether they're mobile or fixed. If you choose the 5G fixed area, you sacrifice the mobility, but if the majority of your customers are fixed, then you don't need it. And it results in a simple to deploy, lower cost solution. Another use case is shopping malls, for instance. In the past, these have been enabled, or connection to the communications have been enabled by a 5G small cell deployment. 5G small cells, yes, they're less complex in terms of the equipment cost, but you still require that complexity of the core and the EPC that manages the network. An alternative to this would be to deploy a 5G fixed network that can backhaul Wi-Fi data. Every UE, every device has Wi-Fi connectivity, so why not use that ability to then capture the data from end users, the data with the 5G fixed network. That roughly equates to a 5G mobile experience in these campus and enterprise locations like shopping malls. So in summary, Cambium believes we can deliver a 5G fixed solution and deliver results. Utilizing a software-defined, purpose-built 5G fixed solution, we can optimize performance for fixed wireless and future-proof things, allowing new features and the evolution of the platform. By utilizing beamforming and massive multi-user MIMO, we're maximizing throughput at the sector, but minimizing interference at the end user, at the subscriber side. And with low latency architecture, we have sub 2 millisecond latency, we can satisfy the most demanding applications, including gaming, which has become more important of late. With our highly directional and high gain CPE, which is a key differentiator for the system, we're able to achieve link balance. We can go farther range with our CPE equipment than other solutions in this space. All that said, this is what we believe is a perfect solution for fixed wireless service providers who are wanting to push more data through those rural and even into suburban density areas. It is also well suited for private 5G networks. So a managed service provider or an operator who does carpeted space, enterprise, campus, or shopping malls can provide capacity to those with our purpose-built 5G fixed solution. Thank you.